Welcome to Girls Who Maths. I'm Libby. You'll meet Alex in the next set of videos. Today I'm going to go through the AQA higher paper from 2019, that's paper 1. In the next set of videos, Alex will go through paper 2 with you. So let's get started. Question 10. So it says the number of items made in 1 hour by a machine is given by this equation, n equals 60 over t, with t being the time in minutes that the machine takes to make one item, and note that the value of t changes for different types of items. Now the first part of this question, 10a, gives us a grid. Obviously yours will be much prettier and this will be brilliant on the paper, but I've just drawn it out here. On this grid, draw a graph of n equals 60 over t for the values of t from 1 to 4. So what it wants is the n values at these different t. So let's have a look. Well, when t is 1, what's the value? So it's going to be n 60 over 1, 60. Now we repeat this for 2. 60 over 2, 30. We do it again for 3, and we're going to do it again for 4. 60 over 3, 20, and 60 over 4 is 15. Okay, so now we have them for our values of 1 to 4. You can do intermediate values if you want, but for this question we don't need to. So let's start with t is 1 and n is 60. So we find 1 on our graphs. You've got lines on your graphs, so you need to make sure that these points are super accurate. So you go up, t is 1, and we go to n is 60. Which is approximately there. Repeat this for the other 3 points. So t is 2 and n is 30. If mine looks a little bit off, it's because I'm drawing it from an angle. T is 3, n is 20. And when t is 4, n is 15. So it's approximately there. And then because it wants a graph, we need to draw in them lines up. So you want some kind of curve that goes to all your points. Don't extend it either side because it says from 1 to 4, so it needs to only be between those limits of t. 10b now is a follow-on from this question. I've left the graph here because we're going to need it. So the machine takes 3 minutes and 30 seconds to make one item. Use your graph to estimate the value of n. Now you'll see this one's worth 2 marks, but it's only giving you 1 line. And also use your graph is shown in bold. That means that it's going to look at your graph for that extra mark. So you're going to get 1 mark for your answer and another mark for using your graph and showing evidence of that. So it takes 3 minutes and 30 seconds, which we can write as 3.5 minutes, because that is our time. And time, this graph is shown in minutes. So that's what it is in minutes. Now, we need to use that to work out the value of n. So we look for 3 minutes 30 on our graph. We're going to draw a straight line up until we hit our line that we've drawn. So if you didn't get part A, just draw a line on your graph, any line, doesn't matter if it's accurate or not, just try and make a best guess at a line so you can do this question, because it's important that you're using a line on a graph to answer this. So just draw a line on and then you can answer this question. So we go 3.5 up, we hit the line, and then we go across. Obviously yours will be much more accurate than this, use a ruler if you can. And then you want to read off that point. So I would say mine is approximately 18. Yours will vary and it will give a little bit of lenience on the answer, but it will depend on how you've drawn your graph. So they will mark it based on if you've done that accurately or not. So for me, my n is 18, yours might be 17, yours might be 16. But as long as you've used your graph accurately, that's fine. So for this one, n is 18. Question 11 says, Ed and Faye shared £335 in the ratio of 7 to 4, which means Ed is 7 and Faye is 4. Remember, it's the order that counts. So Ed then gives Faye some of his money, and Faye now has the same amount as Ed. How much money does Ed give Faye? Well, let's work out how much she started with. So we have our ratio here. What we do is we'll add up the total of that ratio. So we'll add up 7 and 4, and that gives us 11. And what that means is we need to share our pot into 11, and then we can give 7 of that 11 to Ed, and we can give 4 of that 11 to Faye. So let's do that. Let's do 330 divided by 11. That equals 30. So 30 times 11 is 330, so that's how we know that that is 30. Okay, now 7 lots of that goes to Ed. So Ed gets 30 times 7, 210. Faye gets 4 lots, so 30 times 4, which equals 120. Remember, that should be the whole of the pot divided. So we add those together, that does equal 330, so we're correct at this stage. Okay, there's a couple ways to work this out. I'll show you one, you might have done it a different way, and that's absolutely fine. Just make sure we have the same answer. So, the difference between these two is £90. Okay. So the difference between what Ed's got and what Faye's got is £90. And we want to know how much it takes to get them to the same amount. So, if we divide this by 2, if we do 90 divided by 2, we get £45. Now, if Ed gives £45 to Faye, his number will go down by 45. So Ed's will become 210 minus 45 pounds, and that equals 155. Is that correct? Sorry, 165, that's what it is. Non-calculate questions can be quite tricky, so make sure you have got that right. That is, yeah, 165. Let's rewrite that to make that a bit easier for you to see. 165. So, now let's look at Faye's value. So Faye's getting money off Ed. So her number's going to go up by £45, which means hers is also going to be 165. So they're going to have the same answer. So all I've done is taken the difference, divided it by 2, and said that he's going to give up that 45. She's going to gain that 45. So Ed has given £45 to Faye. So Ed gives 45 to Faye. Now remember, it's asking you for that number, so make sure it's clear that you've decided that. This calculation doesn't necessarily make that clear, so a little statement at the end is always helpful. Question 12 is a nice easy one marker. The next term of the sequence is made by adding the 2 previous terms. Which of these sequences follows this rule? So let's just go through each one and see if it follows that rule. So we're adding the 2 terms to get the next one. So minus 9 add 2 is minus 7. Yes. 2 add minus 7, which really means 2 minus 7 is minus 5. Minus 7 add minus 5 really means minus 7 minus 5 is minus 12. So the first one is correct. Now what we should do in this case is just check the rest to make sure we haven't made a mistake here, and just check that the rest don't follow the pattern. So 0 and minus 3, if we add those we get minus 3, yes. But if we do minus 3 add minus 3, it really is minus 3 minus 3, it makes minus 6. Not 0, so that one's wrong. Minus 2 add 5 is plus 3, so it's not that one. Minus 1 and minus 1, yes, it makes minus 2. Minus 1 add minus 1. Add minus 2, sorry, yeah, it does make minus 3. But minus 3 add minus 2 add minus 3 really is minus 2 minus 3. Doesn't make 1. So it's not that one, it's not that one, or that one. Means it has to be that first one. Question 13 now. This is looking at the volume of a prism. So it says the triangular cross section of a prism is an isosceles right angle triangle. So that means that 2 side lengths of that triangle are the same length. So x and x are the same length. That's why they're drawn on both here. The volume of that prism is 102 centimeters cubed. And use approximations to estimate the value for x. So those values there, it wants us to estimate the answer. You must show your working, so that's important. Must is in bold, so to get the marks we have to show working. Okay. Now let's look at the approximations. So Approximations are tricky. You don't want to oversimplify it and make it a huge approximation to a really easy number, but you also need to simplify enough that you can work out the answer. So we have two numbers here. We have 8.14 centimetres and 102 centimetres cubed. So let's approximate those two numbers. Start with this length here, 8.14. So approximately that equals 8. We could approximate to 10, but that would be a little bit of an over approximation. 8 is a good number to work with, so we'll stick to 8. So we'll approximate that side at 8 centimetres. The volume of 102, we'll approximate that to a nice round number of 100. Okay, so now we've got some approximations to work with, we can work out the answer. So the volume of a prism like this, the best way to do it is to do the cross section, which is the isosceles triangle, and times that by the length. So the area of the triangle, we'll work that out first. The triangle is the length times the height, so x times x, as if we're working at a square or a rectangle, but then we divide it by 2 because we only have half of that, and that's why we have a triangle. So divide by 2, which simplifies to x squared over 2. Now for the volume of the prism, we do that area, we've got x squared over 2, and we times it by the length, which is 8.14, but remember we approximate that to 8, which gives us 8x squared over 2, 8 over 2, 4, 4x squared, that's the volume. And we now know the volume is 102 centimetres cubed, remember, approximated to 100, so that volume, 4x squared, is equal to the volume that we know, 100. Now all we've got to do is solve this equation for x. So let's move the 4 over, just come from times to a divide. Divide by 4 gives us 25. And then we square root this side. So we square root 25 and that gives us 5. Now remember, when you square root in a number, it could be a positive or a negative number. It could be minus 5 or plus 5. But obviously, in this case, we can't have a minus side length. That wouldn't work. So it's a plus in this case. So we're just going to leave it as 5 centimetres. X is 5. Question 14 now. So it gives us a quadrilateral with angles A, B, X and Y labelled, and a couple of bits of information underneath. So A is 90 degrees. The relationship between A and B is of a ratio of 5 to 4. The ratio of X to Y is 1 to 3. It wants us to show that B equals X. So this is the kind of question where there'll be a few different methods to get to the right answer, and that's absolutely fine. You might have done it a different way to me, but as long as you have the correct values for B and X, and you've also shown enough steps in your working that shows how you've got there, then that should be absolutely fine. So I'll show you how I've done it, but it's okay if you've done that differently. Okay, now quadrilaterals. What we know about quadrilaterals as a rule is that inside angles, all of them, add up to 360 degrees. So let's write that down. So all the angles that we have add up to 360 degrees. So that's a rule, that's what we're going to use a basis for, but we're going to leave that there for now. Let's look at what else we know. So these two bits of information here, we know that A is 90 and that the ratio of A to B is 5 to 3. Okay, that means we can work out B. If we know A is 90 and we know A takes up 5 portions of this ratio, we divide it by 5 and that gives us what 1 portion in this ratio would be. So we know 90 divided by 5 is 1 portion of this ratio, and B has 3 portions of this ratio. So we work out what 1 is and then we times it by 3, that gives our ratio. So 90 divided by 5, 18. 18 times 3, 54. So B is 54 degrees. Now, if we look at the next ratio we have, it's X and Y and it's a ratio of 1 to 3. So we don't have any information on X and Y yet. So let's go back to this rule that we started with. We know A now is 90. We know B now is 54. We don't know X yet, we don't know Y yet, but we know it equals 360. So if we move these across, we can work out what X and Y is. So X and Y is equal to 360 minus 90 minus 54. And that might take a few steps of working, so it's quite a long subtraction. 360 minus 90 is 270. We then minus the 54, so we minus the 54 first. 220 minus the 4, 216. Okay, so we now have an equation for x and y, and we also have a relationship between x and y that we can use to solve this equation. So we know that the whole thing is 4. 3 and 1 added together makes 4, so the ratio accounts for 4 portions. And we know x is one of those portions, so the 4 lots of portions must equal this number there, because we know x and y, and we know that the ratio is 1 to 3. So what we can do is we can write that 4 from that ratio in terms of x, because x is only one of them. So if we times them by 4, we get the whole lot, and we know the whole lot, 216. So we divide that by 4, we move the 4 across and divide by it, which gives us 54. Now we can also work out y here, but we don't need y. It doesn't want y, it wants b and x. B, got that, 54. X got that, is 54. So b equals x, and that equals 54. And that has shown enough to get us the marks for that answer. Question 15 now is a cumulative frequency question. So it's given us information about the test marks of 120 students. Yours will be split into 2 tables. This will be shown in the first part, and then cumulative frequency table will be shown in 15a. I've just combined it here for ease, and obviously excuse my appalling attempt at a straight line. So it's given us the marks and the frequencies, and it's given us a couple of stars for the cumulative frequency, and what it wants us to do is fill in the remaining numbers. So cumulative frequency is basically you take your frequency and you add it up. So you're looking at how it accumulates over, in this case, marks. So you will notice here I've combined this, but really the cumulative frequency is marks less than 20. It doesn't include the 10. So we're looking at marks less than 10 in this case. There is only 20 of those. But less than 20, we have the ones that are between 10 and 20, and also the ones that were less than 10, which is why we've got 48. We've added them together. Now, the cumulative frequency here is the marks less than 30. So less than 30 is still the ones that are less than 10, the ones that were less than 20, and the ones that are now less than the 30. So we've got 48. We know that that combines those two, and we add on that extra 40 to account for that extra 10 marks that we just included into our inequality. So 48 and 40, 88. Now again, we're moving up to marks less than 40 now. So we've got the marks less than 30. We add the marks that were between 30 and 40. That gives us 20, so that gives us 108. 20 out of 88. We do the same for the last set of marks, which was marks less than 50. 108, and we have 12 of those. 120. Now, the thing about cumulative frequency is it should include all of the people in the test. So as long as the test bounds, so the marks in this case, included all the students, then you should end up with the cumulative frequency of all the students, because all the students must have scored somewhere in this range, so they all must have scored less than 50. So we have 120 students, we have 120 here, so that's a good indicator that we've done that correctly. Now we're on to 15b. So 15b wants us to use the information from 15a, so these cumulative frequencies, and plot the graph, the cumulative frequency curve. You'll have seen it, it looks a bit like a very stretched out S. So that's what we're aiming for here. Now obviously your graph again will have all the lines on. You should do it really as neatly as you can, but obviously here I've drawn it out so it's not going to be quite as neat as yours will be. So we look at them top bounds. That's what we're going to plot our points at. So we want to plot the point of where those people are less than. So less than 20, there's 10, less than 10, sorry, there's 20 people. So we find our marks of 10 and we mark a point there. So at 10 marks, there's 20 people less than it. At 20 marks, 48. Make sure you're doing this nice and accurately on your graphs. Less than 30 is 88, so we find 30, we go up to 88, which is probably around there. We go less than 40, there's 108. Up to what is approximately 108. And less than 50, there's a whole lot, which is 120. and we connect them. So 0 people have less than 0, so make sure you're starting at 0 and you're going to go through all those points with a nice smooth as you can curve. That's your cumulative frequency graph. And then we have the final part of 15, which is 15C, and it tells us that students who score 15 marks or less take another test, and it wants us to use our graph test to estimate how many students take that other test. So the fact it says use your graph means it wants to see that you have used your graph. So this is the point where we draw a line in our graph. So 15 or less is the number we're looking for. So we're looking for 15 on our graph, and that's 15 marks. So we go find 15, obviously make sure yours is accurate. You'll have them lines to guide you. Use a ruler if you can. Up from 15 and a straight line across. So mine is giving a result of about 40. So students, it's 40. So my graph is telling me that the frequency of people who scored less than 15 is 40. So from my graph, the estimate is that 40 people need to take another test. Your graphs may vary slightly, so make sure you just read yours accurately, and there will be discrepancy in the marking for variations in exactly where that curve lies. But as long as you've drawn that line straight up to your curve and straight across, you'll get them marks. So just make sure you've shown that on your graph. So for mine, the number of students that need to take that other test is 40. We're on to question 16 now, so we're getting there with this paper. It wants us to simplify fully 4x minus 8x squared over 12x minus 6. So by simplify fully, that means that it wants us to take out everything that's in all the, it's a multiple of all of these, pull that outside a bracket, and we want the bracket in the most standard form we can. So we can't remove anything else from that bracket. It is as simple as it gets. Now the way to do this is look at the top and the bottom separately first. So let's look at the bottom because that's quite simple. There's only one x to deal with. 12x minus 6. Okay, so what can we take out of this? What is a frequent in both of these terms that we can pull out of the equation? Well, there's an x, but it's not in the second part, so we can't take that out. But 6 goes into 12 twice, and obviously 6 goes into 6 once, so we can remove a 6. That leaves us with 2x to make the 12, and 1 minus 1, remember, to make that minus 6. So that's the bottom part of the equation. Now let's look at the top part. To simplify fully, what we want is the same fraction on the top and the bottom, so we can cancel them out. Remember, if you divide them by the same thing, you can just cancel it. So let's see if we can do that. Can we get the top of the equation to simplify to 2x minus 1? Well, we can remove an x, and x is present in both terms. So if we remove that x, we're left with 4 minus 8. Okay, now if we want a 2x at the start, we need the 8x to go in front. To do that, we need to swap the signs around. So we need this one to be a plus and this one to be a negative. And to do that, we can take out a negative, that'll swap the signs. So now, with that negative out, we've got 8x minus 4. And you'll recognise 4 goes into 8 twice and 4 goes into 4 once. So we can put that 4 there. And now what we're left with is 2 parts of the fraction with the same common shared bracket. So we can cancel them. So let's write it out. Minus 4x, 2x minus 1, and that's over the top one, which is 2. X minus 6, and that's times by 6. 2x minus 1, sorry, times by 6. Right, we can cancel that, we can cancel that. 4x6. Now remember the question says to simplify fully. Is that simplified fully? No. Both the top and the bottom are also divisible by 2. So we can divide it by 2, and we'll get on the top 2, and on the bottom 3. There's no part of 2x or 3 that are common anymore, so you can't simplify any further, which means the answer must be minus 2x over 3.